Hi, so this question is Fibonacci number. So Fibonacci number commonly denote f of n form a sequence such that each number is the sum of the two preceding ones. So this question is supposed to be really straightforward. So if f of 0 is equal to 0, f of 1 equal to 1, then f of n is actually equal to f of n minus 1 plus f of n minus 2. So I can say f of 2, f of 2 is actually equal to f of 1 plus f of 0, right? So this is also equal to what? 1 plus 0 is also equal to 1. So if you are given the arbitrary number like n equal to just 1000, right? So you are going to say f of 1000 is also equal to what? F of 999 plus f of 998, right? Then if you want to just keep going, then f of 999, you have to find 998 and also 997, and for f of 998 you have to find 997, 996, and then if you notice that you are actually traversing that multiple times for the number, right? So without keep searching the number you already find, you need to have a memorization map, something like this, right? So I'm going to demo one. First thing is going to be without the memorization map, and another one is going to be with the memorization map, and another one is going to be using DP. DP is also actually equal to the memorization map, but I don't need to store all of the number. This is because I only need to know my previous two and also the current one, right? I only need to know the sum of the two preceding one, right? And also the current number. So let's just start the solution. So I'm the first one without memorization map, something like this, right? So if n is less than what? Less than 1. No, sorry. If n equal to 0, I'm gonna say return 0. If n equal to 1, I'm gonna return 1, right? And then in pre equal to 0, current equal to 1, right? I'm actually make this as a default, pre and current, right? Let me say pre 1, pre 2. Okay, pre 1, pre 2. All right. Then I'm gonna starting from what? I equal to 2, I less than equal than n, I plus plus. All right, you definitely need an equal, right? Because you need to traverse until what? F of 2, right? So the current sum is actually equal to pre 1 plus pre 2, right? And then once you have this, right, the next iteration, f of 3, you need the current pre 2, current 1, and then also the current sum, right? So I'm going to just get rid of what? The pre 2 is also equal, okay, pre 1 is also equal to pre 2, and then pre 2 is also equal to sum. So now you want to return what? The current sum, right? So this is going to be what? Pre 2. So let me think about this. Yes. So pre 2 will also equal to the sum. You don't need to return the sum because pre 2 is the keyword that you need to return, right? And then sum is just a local value for every single iteration. So if you still don't get it, I'm going to draw a little bit diagram. So this is this is 0, this is 1, this is 2, and 3, right? So I'm actually initializing my what? The value 0 and 1 right here, right? And then my sum is actually equal to what? 0 plus 1 equal to 1. And my pre-1, this is pre-1, right? This is pre-2, right? So pre-1 is also equal to what? Pre-2. So I'm assigning my pre-1 to 1. So P1 equal to this number 1. And then P2 equal to the current number that I find, right? This is 1, right? this is the f of 0, f of 1, f of 2. This is f of n, right? And then I already know this is 1 already, right? So for the next iteration, for f of 3, I need this number and also this number, right? So this is how I assign, right? F of 2 assigned to the current sum. So when I want to return, I only need to return the pre-2. You can also return sum, but the sum is inside the for loop, so you cannot say return sum over here. So this is a basic idea, right? So submit. Alright, so for time and space are pretty straightforward. This is f of n, all of n for the time, and space is constant, right? So this is without memorization map. And then another one, if you want to remember every single number, right? Every single number, I can create a hash map, right? Hash map, integer, map equal to new hash map. And then if n equal to 0, return 0, right? If n equal to 1, return 1. Alright, so this is actually, I didn't initialize my map, my key when key equal to 0 and when key equal to 1, right? So this is a little bit dangerous. So the best thing to do is you need a helper function and then using a recursion. So probably int fib, and I pushing my hash map into the function integer and then map, and also I need to pass in the n. So I want to return the fib of new hash map, and I pass in integer map, and then this is n, right? This is a little bit ugly, but doesn't matter. So if n equal to 0, return 0. If n equal to 1, return 1. Now, if I find this number already, which is n, I'm gonna return method get n. So how do I find this number? I need to store, right? I need to store my value. So I need a val for what? For fib map n-1 plus fib map n-2, right? I need to store this value into my map, right? I need to pass in the n, because like you want to decrement your n. For every single n you will get a value, right? F of 2 equal to 1, f of 3 equal to 1 plus 1 equal to 2, so f of 3 equal to 2. So you want to return the val, right? So what did I get wrong? So probably this one, and I don't need a name, right? Okay, yes. So this is memorization. So in this one, the time and space are the same. This is because you store every single element, the summation for each sum, into the map, right? And also you traverse every single element in from 1 to n, right? So the time and space are f of n, and n represent end of the n as n, right? And let's talk about another solution. You only need two two preceding number, which is also equal to the first solution I mentioned, but in this one I'm using the DP. So it's gonna be what? It's pretty similar, but in this one I'm actually still I'm using the DP to store every single element, right? So DP 0 equal to 0, DP 1 equal to 1, right? And I still need to have a base case. If n equal to 0, return 0. If n equal to 1, return 1. And I still have to traverse n equal to 2, I less than equal than n, I plus plus. And then a dp at I is equal to what? dp at I minus 1 plus dp at I minus 2. And then you will just basically return dpn minus dpn, right? Yes, because you need to traverse until what? N, from 0 to n, right? So this is how you initialize your size n plus 1. You need to include the index 0. So forget. So this is the memorization stuff. I mean, yes, because you need to store every single element, right? So it's like hash map. But if you want to optimize the solution, you can just say size of 2 for the DP, and this will be exactly like the first one. But just before I rewriting, I'm going to talk about the time and space for this one. I almost forgot. This is all of n for the time, all of n for the space, right? And just a little bit updated. So f of 2 and exactly the same dp 0 plus dp1 and dp0 equal to dp1 equal to sum, right? And I will return dp1, right? So this is exactly the same as the first solution. If you don't believe it, like just wind back and then I mean rewind back, and then you will definitely see it, right? And what else? This is pretty much, right? So the time and space, this is f of 2, and for the space, and this is all of 2, well, which is constant for the space. This is all of n for the time. Alright, so Fibonacci number is pretty standard LeetCode question, so you definitely need to know like how to use a DP as your solution, or using the hash map for memorization solution. So this is pretty much a solution. So if you feel helpful, subscribe, like, and I will see you next time. Bye.